Welcome to this comprehensive guide on using PyTorch with AMD ROCm for AI computing. As a developer, you're likely familiar with the benefits of open-source GPU technology and its growing importance in machine learning and deep learning applications. In this video, we'll explore the setup process, benchmark your GPU performance, and share best practices for efficient deep learning with PyTorch on AMD ROCm. To get started with PyTorch on ROCm, you'll need to install the ROCm software stack on your Linux system. This includes installing the driver, runtime, and development tools. Once installed, set up a Python environment using conda or pip to ensure compatibility with PyTorch. Finally, verify the installation by running a sample code to test the functionality. When it comes to performance, PyTorch on ROCm delivers exceptional results. In terms of FP32 throughput, you can expect speeds of up to 2.5 teraflops. For FP16 operations, the speed increases to 5.0 teraflops, while memory bandwidth reaches an impressive 400 gigabytes per second. To get the most out of PyTorch on ROCm, follow these best practices. First, use data parallelism to distribute computations across multiple GPUs and maximize performance. Second, optimize your model architecture to take advantage of ROCm's capabilities, such as its high-performance tensor cores. Finally, utilize ROCm's built-in libraries for efficient memory management. To benchmark your AMD GPU, you'll need to run a series of tests using ROCm's built-in tools. This includes the ROCminfo command for displaying GPU information and the ROCmsme command for monitoring system metrics. Thank you for watching this comprehensive guide on PyTorch with AMD ROCm. Join the #AMDevs community to stay updated on the latest developments in open-source GPU technology and connect with other developers who share your interests. Don't forget to like and subscribe to our channel for more informative content.